Greetings, everybody. So far we've done a lot with making things move around and screen wrap and bounce and so forth, but they've just been simple shapes. We can do game mechanics this way, but we can't make games look really nice. So in this video, I'm going to show you how to add a background image, how to make a background image move if you want, and also how to make the objects in your game be actual images of things rather than rectangles and circles. So let's start by choosing some images. I'm going to go ahead and search for space background inside Google Images. And let's choose something that's sort of nice and neutral here. This one looks okay. So this is just for my own personal use, but if you were going to actually do something with these, you would want to make sure that you have an image in the public domain. In the meantime, I'm going to save this image. You're going to need to save the image inside the folder where your code is. So in order to do that, you're going to have to find it in your file system. So the first step is going to your workspace. If you don't remember where your workspace is, Eclipse will tell you. You can actually go to File, Switch Workspace, Other. And now it tells me that my workspace is in the D drive, David Java Workspaces 2016 Intro Java. So actually, I'm just going to go ahead and copy this so I can paste it. So I'm going to paste the path into here and hit enter. So now I'm inside my workspace, but now I actually have to go to the project that I'm in. I'm working inside the project Graphics Experiments. And what I'd like you to do is create a new folder in here, which we'll call Resources. And we'll put the image inside the Resources folder. I'm going to call it spacebackground.jpg. Cool, so I've saved it. Let's grab another image. I'm going to search for SpacePie. SpacePie. Maybe, actually, I'm just going to search for the word pie. I'm going to choose something that's got like a background that I can cut away nicely. This looks like a great pie. Okay, so I'll save this one as well. And I'm going to save it in the same spot. I'm going to go to David and Java Workspaces and 2016 Intro Java and Graphics Experiments, and then here's my resources folder, and I'm saving it in here. And I'm going to just call this one pie.jpg. Okay, now that we've done that, let's actually look at the resources folder inside Graphics Experiments. So I went ahead and I created the resources folder, but you don't actually see it here. You would if you right-clicked and you said refresh. See how it added the resources? If that didn't happen for you, then that means that you created your resource folder in the wrong place. So you've got to figure out where is the folder that actually is storing all your code and go back and do that whole process again, because otherwise nothing is going to work after this. Okay. So I've got resources that are pie and space background. What I'm going to do is I'm going to add this resources folder as a place where this program looks whenever it's trying to find things like images. This process is actually similar to adding a jar file. So I'm going to start here and click on Graphics Experiments. I'll right-click, go to Properties, select the Java build path, then the Libraries tab, and finally I'll say Add Class Folder. Graphics Experiments is the name of my project, and I'm going to select Resources as the folder that I want, because this is the folder where I've saved all my images. I'll click OK. And now that I've added it, everything after this should be pretty easy, as long as you're sure that your images are really in the right spot and you know what they're named. So without further ado, let's create a background image. There are 3 steps here. First, you have to create a new data type called pimage. And let's name our pimage background. This is something you have to hover over and say import, because a pimage is a special piece of code that comes with the processing library. Okay, so now that we've got a pimage variable, just like these other variables, I have to save a value into them. Here I have to save my image inside this pimage variable so that I can use it later. So I'll say background equals load image, and now the input to the load image command is a string that contains the name of my file. So space background.jpg. Okay, this step is only going to work if you did that thing with the class path. Otherwise, you would have to put something called the absolute path to your file name, which is a path starting with the drive letter and then having a sequence of folders that tells it where to find it. All right, so that loads the image, and now I'm going to use it. So instead of using my background here, I'm going to delete that, and the command that displays an image is called image. And then I give it a pimage variable, like background, and then I tell it where do I want the upper left-hand corner of my image to be. So here, I want my backgrounds to cover the whole screen. So if I make the upper left-hand corner of the background at 0, 0, I know it's going to cover the whole screen. Let's run it and see what it looks like. Okay, well, I'm noticing a couple things. One is that it's not quite big enough for my window. And so that means that I actually see the trail being left behind by the ball when it goes over the image. So you got a couple choices here. You could open Space Background inside a photo editor and actually change the size so that it matches the size of your window. A different thing you could do is here I could tell the image to resize itself. I can say background.resize, and I can just give it new coordinates. So for example, I can just tell it to resize to 600 by 600. I'm doing this inside setup because this is kind of a slow process, and I don't want to do it inside draw, which is happening all the time. I want to do it once right here, and then I'll just use the results inside draw. So let's take a look now. Okay, that's okay. It definitely looked like it warped a little bit when I resized it. So if you don't want it to warp, there's one more thing you could try. Up here, not only can I tell the background image to resize itself, I can also ask it how large it is right now. So background.width is its width in pixels right now. And background.height is its height in pixels. Well, this right now wouldn't do anything because I'm telling it to resize itself to its current width and its current height, so that wouldn't change it at all. But what I could do is I could tell it to resize itself to be twice as large. So that would keep the same aspect ratio, but it's just going to zoom the whole thing in. That seems like it's zoomed in too far. So if you want to, you can specify like maybe 1.4. We can find a smaller scaling factor. It probably wants a float or possibly an int. So let's actually cast it to int. Okay, let's try it now. That's pretty good. That's better. You can tinker with it on your own. All right, let's do the same thing and replace the ellipse with the picture of the pie. So I'm going to add another p-image, but instead of background, I'm going to call it pie. And then here I'm going to call this load image. What did I call it? Pie.jpg. And let's resize the pie to be 100, 100. And now down here, instead of an ellipse, I'm going to comment that out, and I'll draw an image. And the image is going to be my pie variable, but I want it to draw at my coordinates x, y. So before, I drew an ellipse that was centered at x, y, and the numbers inside here change, which is why the ellipse moves. Same thing. So here I'm going to draw an image, but I'm drawing it at whatever coordinates I used to be drawing my ellipse at. So now we see a pie that's kind of bouncing around. Well, that's very pleasing. There's a couple things that we want to fix, though. One is we've got this ugly white background. Another issue is we might want to actually make the bouncing look nicer so that when the edge of the pie hits the edge of the screen, it bounces instead of kind of going off the screen. Okay, so in order to get rid of that ugly white background, we're going to need to edit the image itself and to cut away the background to make it transparent. So I have a program called paint.net, which I like to use. If you have Photoshop, it's even better. So I'm going to go ahead and open paint.net, and now I'm going to open the images. So I'll go find them again. So where are they? They're in David, Java Workspaces, Intro Java 2016, Graphics, where is it? Graphics Experiments, Resources. Okay, so I'm going to open Pi. And there's the Pi. So I'm going to use the Magic Wands tool. Sure, when I exit. I'm going to use the Magic Wand tool, and I'm going to select the entire white background of the Pi, and I'll just hit the delete key once, and now you see it's transparent. That's what that checker pattern means. Okay, what if you have a more complicated shape where the Magic Wand tool doesn't magically select the right thing? In that case, you could use a different tool, for example, the lasso tool, and you would very carefully click and drag and try and trace out the image that you want to save. That's a really rough job, but it serves its purpose. And then you can say, what do I want? I can say invert selection. And now I've selected everything that used to be unselected. And now same thing, you can hit delete and you have a transparent background. Okay, I'm going to go back to the first thing I did. Cool. Notice how my image is cropped very tightly to what I actually want to display. If there's a whole lot of empty space around, even if it's transparent, you still want to cut it. So what you do is you'd take the rectangular selection tool and you would drag a rectangle that's just the right size for what you actually want to display, and then you could say image crop to selection. Okay, when everything's done, we're going to save it as a PNG file. So I'll go to File, Save As. It's in the right folder, but instead of JPEG, I'm going to call it PNG, and it's called pi.png, and I'll save it and click OK. And now we're in a good position to look at it again. So pi.png this time instead of pi.jpg. And you see when I run it, great, now I've got a nice Pi that displays in the way that I want over the background. We know about the ellipse command that the XY coordinate that you give it will be the center where it draws the ellipse. For images, when you say image XY, the image displays with its upper left-hand corner at those same XY coordinates. So if you imagine the ellipse bouncing, it used to be that when the center of the ellipse hit a wall, that's when it bounced. Now imagine the image here. This is my image of the Pi. So if the image of the Pi bounces around, it's when the upper left-hand corner hits that it's going to bounce. Well, that's actually really great for the left-hand side of the screen, because if the left-hand side of the image hits the left-hand side of the screen, that's what we'd want it to look like when it bounces. The problem is if you imagine bouncing off the right-hand side of the screen, when it was the ball, again, it was the center of the ball, but when it's the image, it's the upper left-hand corner of the image. So in that case, the Pi is entirely off the screen when it bounces, because it's actually the left-hand corner that's doing the bouncing. So what we want to do instead is we want to display the image so that it's centered on the XY coordinates instead of on the left. So let's change the coordinates that we're giving it. What I want to do is I want to tell it to move the upper left-hand corner of the image up exactly half the size of the image. So in other words, I want the XY coordinates where it draws to be above and to the left of the actual variables x and y. So what are the coordinates up here? Well, if my image is 100 by 100, this point, so that means this is xy right there. So that means this distance must be 50, and this distance must be 50. So I'd want this point to be x minus 50 and y minus 50. It's actually bad to use specific numbers here, because what happens if the size of the image changes? So instead of saying 50 and 50, let's take the width of the image and divide it by 2, so that that'll be half the width. And that's how far we want to shift it over. Same thing for the height. We'll take the height of the image, divide it by 2, and that's how far we want to shift it up. So here what I'm going to do is I'm going to say, display the image not at xy, but x minus the pi's width divided by 2, and at y minus the pi's height divided by 2. So that's going to shift the whole thing over so that now it'll look like the image is centered on the variables x, y. Let's take a look. Okay, well that's a little bit better. At least now the image is doing the same thing that the ellipse was doing. But I still don't want it to bounce when the center of the pi has hit the walls. So let's change these boundaries where we're bouncing. Right now I'm saying let's bounce if x is less than 0, but actually what I want to do is say let's bounce if x is less than the pi's width divided by 2. Because remember, x is the center. So if the center of the image is smaller than half the width of the image, that means the very edge of the image must be going off the screen. Same thing here. We'll have 600 minus pi dot width divided by 2. So let's double check that. Great, so that's bounced correctly on the right-hand side. And it's bounced correctly on the left-hand side. Let's do the same two things here. Pi dot height over 2, and 600 minus pi dot height over 2. And now finally we've got a nice bouncing space pi. What we'd like to do now is actually make it into a game where when you click on it, you're like collecting the space pies or whatever. But I think you'll find that the work that we did before to detect whether or not the mouse is inside an oval won't work. Because remember, even though this image is displaying like a circle, it's actually a rectangle. So now we need a totally different approach to detect whether or not the mouse is inside a rectangle. Come back next time and we'll do that.